Well, hello everybody. This is Miss Janice. How are y'all doing today? I'm just so glad that you're here. We were going to start here today with the kit that you should have received. I was going to show you how to put yours together. I have an extra few, the words or the letters, but I was asked, and that's why I'm asking you to text 971-208-9711 because those texts get first priority, okay? So we're asked to go over some more about the number placement. And yesterday we did, I believe, the 5 digits. So here's the 5 digits right here. So we're going to go over that again. So please get out your paper, pen or pencil. This is for older ones, of course. Those who are adding already, dividing, multiplying, subtracting, and starting to get into their fractions. Probably about the fourth grade. Well, it just depends on how well you're being taught. So I'll give you a little time to do that. This is what our lesson looks like today. We're doing fill-ins, but we're also, hold on. We're doing fill-ins, but we're also doing the numbers placement. This is a different type of puzzle, and the name of it is fill-in puzzle. I'm trying to get it so that it'll focus real good. And then there's also words. But I really wanted to go over the vowels today, so maybe I'll do another video in a little bit. So what you're going to do is, now you have to remember this, when you're teaching your little one something, or your child, or your teenager, or your whatever age, when you're teaching them, what you do is you go over first what you're planning to teach. For example, if you're teaching them how to multiply fractions, what you're going to do is you're going to, of course, text me at 971-208-9711 to get an idea of what it looks like, not from their homework, not from their work at school, but you're going to give them the idea of what it looks like. And what I'm trying to explain is this. In order to know how to multiply fractions or subtract fractions or add fractions or divide fractions, you want to first go and find the rules to fractions. Like, what does a fraction represent? And you get the easiest form that you possibly can get. I'm just saying this while you're finding your paper or getting your paper, or you can pause it, but because I'm not going to pause it, I'm just going to talk. So and I believe I explained this already. When I'm teaching fractions, I hold up a blank piece of paper and I ask the class, what is this? No matter what age they are, they can be 5, 6. Usually when I tutor outside the home, I use the child has to be old enough to go to school. That means that they already know how to hold their pen and pencil, crayon. They know about putting this part of their hand on the table to study it, steady it, the hand. They already have some rules. And so I usually hold up a piece of paper and I say, class, what is this? And they'll say it's a piece of paper. And I'll say, no, it's a dollar bill. And then I say, no, it's a piece of paper. And you know they're going to do that. And then we'll start laughing and we'll until we get to the point where I make them realize that what they say is correct, but what they say is not where I'm going with what I'm saying. So then I turn it and I say, no, it's a dollar bill. After I begin to ask, and I say, if you fold a dollar in half, so what is a half of a dollar? So I'm changing the language. And somebody in the class, doesn't matter how old they are, somebody always answers 50 cents. So I say, if you fold $1.50, you have 50 cents. Now, half is fraction. If I fold $1.50, it equals 50 cents. So I take the page and I turn it this way and I say, I have $1 with 2 squares. So that's $1 with 2 squares. So 50 and 50 should equal $1. So 50 and 50 equals $1, right? So, and then you add it. 0 and 0 is 0. 5 plus 5 is 10. As soon as I show them that, they're like, oh, wait a minute. So I say, how many quarters equal 50 cents? And they'll say 2. So then I fold it in half again. So that means that 1, 2, 3, 4 quarters equal $1. Because remember, this is still $1. And so what they're doing, I call it sight math. So what they're doing is they're learning how to do fractions. I say, and then I teach them fractions by beginning with a $1 bill. And then I say you have to put a decimal for that to equal 50 cents. Anything that's on the right side of the decimal is cents. Anything that's on the left side of the decimal is dollar. Okay? For example, $1.50. Now, you go back to, if you have 1 comma, it reads 1,000. How many numbers you start like that? So you're teaching them backwards. Okay? But now we're talking about fractions. This symbol right here, when you're doing regular math, means minus. But when you're doing fractions, this symbol means divide. And so then you start teaching them symbols. And in reading, this symbol means stop. In math, this symbol, and then you compare symbols to symbols. Okay, you should have your paper by now. And then once I teach them this, no, from then on, I say that's why we're now at algebra yet, because you do not know the symbols. I don't say you don't know the rules or you don't know like that. I just teach them that way. So what you have to do is, and I'm teaching it while you get your paper. So now I'm folding up my dollar, and I'm going to put it in my pocket. So that means that anytime they want to do pocket math, because I start off saying it's sight math, but if they want to do pocket math, what ends up happening is that they really want to know it. Because the older children say, what? There's someone 7 years old in our class. They know that they need fractions. They know that they need symbols. They know that they need signs in order to start algebra. And the older class is going to basically sit down and sit still so that they can learn what they missed. And that's what happens when you do this type of math. You take everything. Remember, I told you take everything and you put it in a learning experience so that they will keep paying attention. It's like future. I know I'm going to get to it, but let me see what it says, because maybe I did miss something. Maybe that's why I don't know how to do algebra. Maybe that's why I can't multiply fractions. I forgot something. So I know she's going to get to it because she's always talking about math. She's always talking about dividing. Math. She's always talking about adding. She's always talking about dividing. She's always talking about subtracting. She's always talked about multiplying. And all of that is in algebra. That's why we have to learn how to add, subtract, multiply, divide in order to get to fractions. Because once you divide, fractions start happening. Okay? All right. So you should have your piece of paper out. And yesterday we went over number placements. All of the numbers. So we're going to do it on this paper right here. So we're going to move this over. And we're going to start off where we left off on yesterday. I'm looking for a dark crayon or a marker or a pen. Let me see if this one right. I found some markers. So how's everybody doing today? Now remember, whatever you're going to teach, however old your child is, you can teach them the same stuff. My nephew was 5 and he had come from Philadelphia, and I don't know if he finished the kindergarten, but when he was with me for about a week, I had him multiplying and I had him subtracting and dividing. And they said, I take him to school and I'm putting him in first grade. He was 5. And they said, he's supposed to be in kindergarten. And I said, he's not in kindergarten. He's in the first grade. So they said, okay, we'll give him a week. And if he's not able to stay up or catch up, then we're going to put him in kindergarten. And of course, you know, he stayed in first grade, and then he was put in the young and gifted class. So he was not only doing multiplying, adding, dividing, subtracting, he was doing science and writing and book reports, and, you know, not full-fledged book reports, but he was learning all this stuff because I would tutor him at home. Okay, so in order to have one digit, of course, you need only one number. Okay, so on this page, there are no one digits. In order to have 2 digits, you have to have 2 numbers. And on this page, it doesn't have 2 digits. In order to have 3 digits, because this is where we left off yesterday, you have to have 3 numbers. And so we're starting at 3 digits. If you have 4 digits, if a 0 is there, it's still 399, 459, 587, 638, 685, 690. Now it's 1,000, because you can count it. See, there's no such thing as 0,600. See, that doesn't work. 0 in a number is just there for a placement. And we're going to go find one. Here's one right here. If you have 4 numbers, let's count the numbers. 1, 2, 3, 4. When you're putting in the comma, a comma goes after you say third space. So this is a space behind the 4. You don't count that one. You go 1, 2, and the 2 is between the 5 and the 0. 3, then you put the comma. So that means it reads 9, the comma says 1,504. See, it's a space. That's all the zeros are when it's in the middle of something. 504. You just have to write and remember 504. 504 is how you write 504. 508 reads 508. 702 reads 702. So let's start there. 702. This is how you can tell. This is 700, 701, 702, 703. See, because it has 3 numbers, and anytime you read 3 numbers, it reads 100. How do you remember that? 100. When you start counting, you go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Two digits read tens. You read tens as 10, 20, 30, 40, 50, 60, 70, 80, 90. Three digits read 100. 101, 102, 103, 104, 105, 106, 107, 108, 109. When you get to 110, 100, you know that you're going to need three digits in order to write it. 100 and the number 10. 224. So there's a 20 there, and then you have to write a 4. So if you're saying 10, 20, 30, 40, 50, if you hear those numbers 60, 70, 80, 90, then that means that you have to use two digits. If it's 290, you write 200, 9, 0. 290. 209, you write 209. That 0 is the placement. Okay? All right. So let's go on. So what we're going to do today, we're going to start off with the 7-digit numbers. Look at those numbers and just write them down as you see them. So the first one is 4, 7, 3, 8, 0, 0, 8. Just write them down as numbers. 4, 7. We're right here. 4, 7, 3, 8, 0, 0, 8. And let's go to the next one. 4, 8, 4, 0, 7, 2, 5. So you got 4, you got 8, you got 4, you have 0, 7, 2, 5. Let's go to the next one. 5, 8, 0, 9, 0, 4, 1. So you got a 5, you have an 8, you have a 0, a 9, a 0, a 4, a 1. Let's go to the next one. 7, 9, 9, 8, 7, 4, 7. You got the 7, you have a 9, another 9, a 8, a 7, a 4, a 7. And those are the numbers that we're going to work with today. And the reason I chose the highest numbers is simple. You're going to have to remember the number placements. So in the first number, touch the one number, because remember, when now you wrote the number, now we're beginning to solve the problem. And when you write the numbers, you write from the left to the right. But when you solve a problem in math, you go from the right to the left. When you write down the number, whatever number it is, if I said 10,842, you will write 1, 0, because I gave you the hint right there when I said thousand. 10,482. So when you listen to numbers that you have to write down, you have to remember the rules about writing numbers. 1 comma is thousand. So if I said 122,000, that means that there's only going to be 1 comma in that problem. So when you write down the number, because there might be something later. So when you write down the number, if you hear 1,000, you write a 1 and a comma. If you hear 2,000, you write a 2 and a comma. If you hear 3,000, you write a 3 and a comma. If it's 4,000, you write a 4 and a comma. If it's 5,000, you write a 5 and a comma. If it's 6,000, you write a 6 and a comma. If it's 7,000, you write a 7 and a comma. If it's 8,000, you write a 8 and a comma. If it's 9,000, you write a 9 and a comma. If it's 10,000, you write a 10 and a comma. If it's 111,000, you write a 1, a 1, a 1. See, 111. That's the secret. 111,000. That means you're going to write a comma. And then you listen to the rest of the problem, okay? If they say 2 million, you already know it's going to be 2 commas. So it's 2,470,000. You write 470,187. 187. So you have to listen to what is being said. When it's time to write number placements, you're listening to what is being said. Then if they say something like, add 2,470,187 to 210. It will look like that. So the hundreds never change, thousands never change, millions never change. And if they said 4 billion, that means you're going to have to write 3 commas. If they say 800 billion, you're still going to write 3 commas. That means they didn't finish saying what they're saying. But if they just leave it there, down here, they say 800 billion, you go 1, 800 billion. Because remember, you need 3 commas. So if it's 800 billion, then you just have to remember your placements. 3 commas is billion, 2 commas is million. 1 comma, 2 comma. 1, 2, 3 commas. If they say 800 billion, 700,000, comma, 7 there, 100, excuse me, 800 billion, 700 million, 872. So you put the 800 here. So you have to remember what they said. But the secret is remembering how many commas equal a billion, how many commas equal a million, how many commas. And remember yesterday I was saying how there's no such thing as like 2,000, 1,000. Because see how it has a comma here and a comma here. 1 comma equals 1,000. 2 commas equal million. 3 comma equals billion. And I told you can add more commas and trillion, quadrillion, like that. But normally they only ask you to go up to 1,000,000. But if you take your time, you can actually count up to whatever you want. Okay, so remember, when you're starting to put your commas, you have to go over 3. So you start here. You go 1, 2. When you say 3, you put a comma. So it's 1, 2, 3. 1, 2, 3. So that number, if you have 7 numbers, you get 2 commas. That number reads 4 million, because that's 2 commas, 738,008. Remember, these are placements. These are just to hold your place. Because if you don't put these there, it wouldn't read that. It would read 1, 2, 3. It would read 47,388 if you don't put those zeros there to hold the place. Okay, let's do the next one. You do it first and then see if you get it right when I tell you the answer. Okay. Started here. 1, 2, comma. 1, 2, comma. So instead of saying 3, 1, 2, 3, comma. 1, 2, 3, comma. 1. So that's 4,840,725. Okay, do the next one. Okay, let's check your answer. Okay, so that's 5,809,041. Okay, this is another one. Let's do that one. Okay. 7 million. See, you do the problem from the right, but you read the answer. After you solve the problem, you read the answer from left to right. 7,998,747. Okay, now if you were going to average these numbers, the first thing you would do is put a line here, put a plus sign, and then you would add them. After you add them, do you remember the rule? If you said divide by the number that are stacked, so you would divide whatever that number is for the answer. Whatever, when you add 8, the 5, the 1, the 7, the 0, the 2, the 4, the 4, the 8, excuse me, the 0, the 7, the 0, the 7. You carry your 1 like that. You carry so you're adding. Then you count how many how many are stacked. How many are stacked? How many are stacked? So you have 1, 2, 3, 4. So you divide 4 by the number that these add up to. Then you get an average of numbers. Oops, sorry about that. So what you want to do is you want to concentrate on remembering the rule of number placement. One digit belongs in the ones column. And normally it'll look like this. They'll usually go, it'll be a chart. And then they have so these are the ones, these are the tens, these are hundreds, these are thousands, these are 10,000s, these are 100,000s, these are million. And you put 1 digit here, 2 digits equals tens, 3 digits equals hundreds, 4 digits equals thousand, 5 digits equals 10,000, 6 digit equals 100,000, 7 digit equals million. Okay? And you do your best to remember that 0 is somewhere in there. If you have 1 0, it reads very good ones. If you have 2 zeros, it reads tens. And I'm going to show you what that looks like when it comes to money. Because if you have 3 digits, it's 100, and 100 pennies, hundreds, 100 pennies equal $1. But see, that's why you need to remember certain rules. Because if I change how you teach, oh, excuse me, if I change how you learn math into money, you will get it. But right now, I use money for fractions, and that looks like this. But you'll still remember the rule. Okay. See, 100 pennies equals $1. All I did was add a symbol. So 100 times 10 equals, when you first start doing timetables, you go here. But see, you still have to remember number placements, even when you're doing money. These are hundreds. These are hundreds. 3 digits equal hundreds. Remember, 1 digit is ones. 2 digits, tens. That means you need 2 numbers to be in the tens category. And you remember 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So if I put 1, 0, 0, those are together. They equals 3 digits. So that's why you can get 100. 3 digits. So when you're counting, you go 100. And then if you want 101, you will have to write the 1, the 0, which is the placement, 1. 112, you will write 1, and then, because 100, 1, then 1, then 2. You have to have 2 digits, because 10 plus 2 is 12. Okay? So 142. So if you say 40 in here, that means you need 2 digits to write 40. 100, write the 1. 40, you write the 4. 2. So you use 3 digits to write that. If you get to 1,000, you need 4 digits and a comma. 1,000. Because right now it's just 1,000. And you can listen to this tape, video, pause it, go back over it, but try to do it at least once or twice or 3 times like that, but in a day until you get it. And then don't write it down. You're using your memory. You remember this. You remember this. You remember this. Because these are just rules that you have to remember. There are rules in everything, rules in reading, rules in writing, rules in math, rules in how to do a book report. What Miss Janice is helping you to do is she's helping you to find an easier way to remember. On yesterday, I explained, I might as well just say the other day because I explained it before, but yesterday I remember explaining to you that in order to do algebra, you have to know how the structure of algebra works. There's a science to math. And the structure, there are rules to math. There's precepts, there's regulations, there's statutes, there whatever word you want to use, but there's things that you have to remember. So when you do math, if you whisper the problem out, it becomes a word problem. So if you do a math, if you're doing math and you see this right here, right? That reads 2 decimal hundredths. 2 decimal hundredths. So you would have to remember what to do with a decimal when someone says write 200 in a fraction. So it'll be like 8 quarters. And this means divide. So 4 goes into 8. 4 divided by 8 divided by 4. So look at this. 4, 8. No matter how many zeros you put after it, it's still going to read the same thing, right? 4 into 8 is 2. 2 times 4 is 8. Then you take away 8. Take away 8 is 0. Then you bring down the 0. 4 goes into 0. Bring up the decimal. 0 times. 0 times 4 is 0. And then you bring down the last 0. 4 goes into 0, or 4 goes into 0. 0. 0 times 4 is, see, it's $2. So what I'm trying to explain to you is that everything that you learn from kindergarten has rules, and there's a way that they taught you how to do it, or there's a way that it's taught how to do. When you learn math, when you begin to teach your little one math, and they don't get it, don't go on. Make sure that they get it. If they don't get it, then that's one rule that they're not going to remember to go to the next part of math. After you learn how to add, subtract, divide, multiply, once you get to division, that wasn't the right order, because first you add, subtract, you multiply, then divide, because that's how you correct your multiplication problems, by dividing. That's how you correct your division problems, by multiplying. And you saw I just divided, correct? So 2 times 4 is 8. 0 times 4 is 0. 0 times 4 is 0. So that's how you correct your problems. You multiply first, you divide first, then multiply. In order to correct your subtraction, you add, like 4 and 4 is 8. But instead of continually adding on, they teach you how to multiply. 4 times 2 is 8, because you have a 4 here. Oops, sorry. And you have a 4 here. You have 2 4s. And if you count those, 1, 2, 3, 4, 5, 6, 7, 8. 2 times 4 is 8. Okay, so there's rules. And once you learn the rules, one digit is ones. Once it gets to 10, 2 digits is tens. Count by each, somebody says count by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90. Once you get to 100, count by hundreds. 100, 200, 300, 400, 500, 600, 700, 800, 900. Once you say 1000, that's 1,000. So that you, when you're counting, you don't say 100, 200, 300, 400, 500, 600, 700, 800, 900, 1000, 1100, 1200, 1300, 1400, 1500, 600, 1700, 1800, 1900. No, you end up saying 1,000. 1,100, 1,200, 1,300, or 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000, 8,000, 9,000, 10,000, right? But you add another. Let's show you. You add another number. 1, 2, 3, 4, 5. So you go 1, 2, 3, and then there's a 10. I wrote too many zeros. 10,000 looks like this. 10,000. Because there's only one zero, but you have to have that 10 there. And then remember, these zeros are placements. And you remember, because after the ones, then comes the tens, then comes the hundreds, then comes the 1,000. Then after 1,000, 10,000. Then after 10,000, 100,000. And after 100,000, there's no such thing as 100,000. So it comes million. Okay? Because you get 2 commas. I don't know how else to explain number placement. So if you have any more questions, please remember 971-208-9711. And the question has been answered. These are the numbers that you can write down. One of the legs is in the way. That's as far close as I can get it. And go a step further, if you will. Start here. And then add those together. Remember to carry. 8 plus 1 is 9, plus 1 is 10, plus 4 is 14, plus 8, 22, plus 6, 28, plus 5, 33, plus 9. And you go, and then you put the line here, you put the last number, you carry the next number. And if you want to work on carrying, just let me know. Work on multiplication, let me know. Work on fractions, let me know. Work on the, because right now we're still doing adding, dividing, multiplying, subtracting. So if someone says, I want to work on fractions, then you just have to remember that you're going to have to go over dividing. We're going to go over again. Well, I don't know whether we'll go over again. We might just, because this number placement is one of the best ways to practice your multiplication. One of the best ways to practice your fractions. Okay, so we did the 7 digits today. So in order to do 6 digits, it will not be a million. Because after you only have the ability to put 1 comma in there. And so it will be in the hundreds, 100,000, like 6, this one, 641,187. You go over 3 spaces, it'd be 705,961. These would be 10,000. Because in order to write 10, you have to use 2 numbers, so 10 and 4. So that would be 14,484. Here's a perfect one. 22,055. Remember, the 0 is a placement. Here's a very good one. 30,000. 853. Another good one. 33,798. This is a good one because it has a placement. So what would that number be right there? If you said 89, you are correct. 37, sorry, 300, yeah, I was right. 37,089. See, you already said 89. You wouldn't try to change it. Okay, then this one right here, what would this one be? Say it out loud. If you said 40,450, you are correct. What would this one be? Remember, don't try to guess. Just until you get it, just go start here, go one space, two space. The third space is where you put the comma. 42,716. And don't be afraid to say it out loud. You don't you want to use your memory. So you count over with your eyes. You put the imaginary comma there, which reads 1,000. So with this one right here, you should get 44,398. Let's do this one. 46,291. So if you have 5 digits, see, this is what you need to remember. If you have 7 digits, you're going to write million. So you count the numbers. If they say, okay, I'm going to give you 7 numbers, you have to tell me how it reads. You already know that you're going to have 2 commas in there. 7 numbers equal million. If you have 6 numbers, it's going to be in the 100,000s. So this one right here would read 641,187. And I know I tell you that all the time because that right there, it stays the same. It's 6 numbers. If they had, I remember being tricked. So if they had 6 placements, and the first number was a 0, it would not read 641,000. If that first number is a 0, you read it just like you would if, like right here. See, because that's a placement. It's 5 digits, and it still reads in the 10,000s. So 30. See, you say, and I'm calling it 10,000s because when you say 10, 20, 30, if you hear 37, that's in the 10, and then you see a comma, 37, comma, 40, comma, 42, comma. So that means 42,000. The comma in math, when you're doing number placement, reads 1,000. If you have 2 commas, it reads million. That means you have to have 7 numbers. If you have to start off with 7 numbers. Because a way to get out of thousands to million, it has to be, remember I told you, no such thing as 1,000,000. Because 2,000, 1 comma means 1,000. 2 commas read million. 3 comma reads billion. If you have 1 comma and you look at a number, you go, oh, I know what that number is. 472,646. Because you look at the number, you only see 1 comma. So it goes up to 100 or 100,000s, 200,000, 300,000, 400,000, 500,000, 600,000, 700,000. So some way, somehow, by you continually listening to the amount of numbers that are in a number and the amount of commas that are in a number, then you know how far you get to go. Okay, so there's millions, 100 million. Excuse me, 10 million, 20 million, 30 million, 40 million, 50 million, 60 million, 70 million, 80 million, 90 million, 100 million, 200 million, 300 million, 400. It's the same way with tens. But when you move the numbers over, you'll understand that the number placement stays the same. And that's why we stopped here on the number placement, because you get 2 commas when you place it in the number placement chart. This is the chart. Okay, let's see. Let me see if I can place a number. I see. Hold on. Let me show you how this works. And these are good for remembering number placement. This numbers fill in. And I suggest that you learn how to read numbers. Numbers are on license plates. Numbers are on street addresses. Numbers are phone numbers. Number placements can be phone numbers. So if there's 10 digits, you see how many commas you get in a phone number. Nine, seven, sorry. I just remembered this part. 1, 2, 0, 8, 9, 7, 1, 1. That's my phone number. So you go 1, 2, 3, comma, 1, 2, 3, comma, 1, 2, 3, comma. So you just practice numbers. 2 commas read million. Very good if you said million. 3 commas read billion. Very good if you said billion. So you did the problem from the right to the left. Now to read it. See, when you read from the left to the right. It's the same with math. 9,712,089,711. So you practice saying numbers. Once you figure out the number placement, see, because there's a 9,711, still the same. There's 2 billion, 8, 9,711, still the same. 9,712,089,711. It won't change. So one day I come up and say, okay, my phone number is 9,712,089,711. And y'all be like, what? I thought your phone number was 971. Oh, it is still 971-20897. Oh. And I'm gonna show you something. When you dial this number like this on the phone, you actually tell the number to pause. It's coding. This is another form of coding. You're telling the number what to do. You're saying 971, pause, because that's the area code. Then you dial 208-9711. So I read it as if I was dialing it. 971-208-9711. Because even if you listen to it and you write it down and then you push it later, it goes deep, 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 deep. There's the pause, and there's a fast pause, but it still pauses. So even if you said 971 comma or 971 dot, because if you write down a code, it tells what to do. That code means phone number. And you're doing math when you play a game. When you play a video game, you're doing math. Someone coded that together, put in symbols, greater than, less than signs. And some of you haven't asked yet about greater than, less than. So I'm just giving you a hint, a heads up, okay? I'm going to show you how to remember this one. Oh, I supposed to be leaving that open so you can find out what word, or excuse me, what number goes with this. But anyway, let me do this and then we'll go to this, back to this one. I just mentioned greater than and less than. Okay? So the numbers line usually starts like this. Oops, sorry. I forgot 3. And if you go this way, it's going to be -1. All of these are positive going that way. But anyway, I thought I'd let y'all know that. Okay, so the number chart goes like this. So that's the number chart up above. So it starts leaving and going off the page. This one starts leaving and going off the page. Okay? 16, 17, 18, 19, 20, -1, -2, -3, -4, -5, -6, -7, -8, -9. Okay, so this symbol means less than. This symbol means greater than. Okay? Now, the way that you remember is because that is the arrow pointing that way. The only thing that's missing is this. See, it's an arrow. See that? This 2 is an arrow. See that? And 0 is in the middle. So I made it smaller. So everything on this side of the 0 is -1, -2, -3, negative, like that. So this is, anything on this side is going to be less than anything on that side. So if they give you a problem that says 8 is greater than, anything that comes after 8 would not be true. Because see, that symbol means greater than. So that's why I'm telling you, you have to read math out loud. That says 8 is greater than, and it'll see it pointing this way. That's what confuses people. That symbol means greater than. So what it's saying is 8 is greater than 7, 6, 5, 4, 3, 2, 1, 0. So you can put anything. 8 is greater than whatever, 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 whatever. Okay? Or another way to say it, 8 is less than. So anything that's going this way, because if you read it out loud, not like you're in class taking a test, 8 is greater than, see, that's not going to work. That is not going to work. But you whisper it, 8 is greater than, 8 is less than. Because you're remembering the symbol and you're speaking what it says. 8 is greater than, because that's the symbol. That symbol, no matter what's on this side of that symbol, it's always going to read the same. This symbol, if it points towards the 0, that symbol will always mean less than, because it's pointing towards the 0. This symbol, no matter what it says, no matter what the numbers are to the left or to the right of it, the symbol is what you're looking at. They're looking for you to understand what that symbol means. That symbol means greater than, because it's pointing towards the higher numbers. See, if they put a 0 here, 0 is greater than, and then you remember everything that's on the other side of the 0. You can put any number, -1, -2. You can put any number. You can put -100, because that's all on that side. See how the arrow is pointing that way? That's what that means. It's the symbol that they want you to look at. They want you to understand the greater than and the less than symbol, not the number. But you have to remember, use your memory to remember what you were taught. Once they start showing you negative signs, they're teaching you algebra, no matter what grade you're in. -8 and -7 equals +15. Because negative and negative equals positive. And these are things that you have to remember. They'll have -1/2, +4, something like that. So if you add it together, you have to remember the rules to adding fractions with whole numbers. So now you got to remember whole numbers. That's a whole number. That's not a fraction. This is a fraction made of whole numbers, but 1/2. So they will want you to change 1/2 into a whole number. And sometimes they give you an answer. 1/2 plus, put a little question mark there, equals 50. But they wouldn't write it like that. I'm sorry. I got to write it like a fraction. So what you do to get used to writing fractions and numbers, and you just take your time and remember, excuse me, you just take your time and go over rules. Now, how did I begin to do fractions anyway? You started doing fractions when you started dividing. It would say something like, with a remainder of 7, and then you would write the answer in a fraction. And then they taught you to multiply that by this. See, so what I'm trying to explain is that you have to remember the rules, and in order to remember them, you start small. You just do a fraction. Excuse me. Excuse me. Okay, so let's do 2 goes into 7. 2 goes into 7, so you need to multiply 3 times. 3 times 2 is 6. Leaves 1, has a remainder of 1. And then you just, like, say for example, you just don't know how to correct that. So you multiply 2 times 3 equals 6 plus 1 equals 7. They tell you to write it in a fraction. And just figure it out, like, okay, now 2. How would I write this in a fraction? Okay. 3 and 1/2. Okay. 3 times 2 is 6 plus 1 equals 7. See, 3 times 2 is 3 and 1/2. But how did I get that? I know that 2 times 3 is 6 equal 1. Oh, so this will go down the bottom. That will, and you figure it out. I mean, but you do it small first. You do it small. You correct it. Okay, I got that. Now, how would I write that in a fraction? 2 times 3 equals 6. 2 times 3 equals 6 plus 1 equals 7. Oh, oh. I mean, you do it so small so that when the problem get big, and this is how you start. Once you know how to add, see, because we did all of them. We did a fraction, right? We did multiplication. There's the fraction. We did division. There's the multiplication. There's the adding. So all of it goes together. So don't think that you don't know how to do algebra. You do algebra, you begin to learn how to do algebra, well, in my case, before you go to school, but you begin to learn how to do algebra by learning how to multiply, divide, add, and subtract. The difference is they put them all together and they add parentheses. They just do it all together. You're adding, you're, you're, I'm sorry, I did this wrong. You're multiplying, you're adding, you're subtracting, and then you get a question mark right here. If you were to write that down, it was I mean, excuse me, well, we're not writing. If you were to say that in a whisper, because you have to get this out of the way first. So 5 times 2 is 10. Once you do the problem in the parentheses, plus 1/2 minus 7. Okay, now we got that problem also. Equals, you cross this out because now you wrote it again. So what I'm saying is you just, once you learn how to do math, reading, writing, then they start talking angles and geometry. Then they start talking like different strategies, giving word problems. But see, if you already know how to do math, you figure out the how to solve a problem. So then you go back to, so you know you're going to have to turn this into a fraction, right? Because 10, unless you're going to do like this, 10 plus a half equals 10 and 1/2 See, and you know that can't be right. But the rule is you have to turn this number into a fraction. And the rule, because of that, is this. You take away the parentheses. So remember, it's please. You multiply. You divide. You add. You subtract. Please, my dear Aunt Sally. So, but if you have a fraction in there, then you have to turn this part into a fraction. But so what your mind begins to do, your mind begins to race, or if it doesn't know the rules, it's like, I don't know how to do it. I'm just going to put any answer. And sometimes they give you answers down the bottom. But before you get to the answer down the bottom, you have to be able to do math in your head. Unless they say, well, you do have the back of the paper to write your problems out. The test is 2 hours long. But once you get finished with the test, you can go home. You can just take up your things, put your test on the desk, and then go home. Or go into the lunchroom or, whatever is next. And the reason it happens like that is because there are some people that do math in their head fast. But it's like if you already know how to multiply, you can do multiplication problems fast. If you know how to divide, you know how to correct it, then you can do division problems fast. You really don't have to write them out if they give you permission not to. So 971-208-9711 if you want to learn any more about adding, multiplication, algebra, but you start with something small first. Okay. See, when it comes to math, you have to remember what you know and not just give up and say, what does that have to do with me going to college or whatever? What does that have to do with me being a doctor, scientist, a chemist? Okay, so how you do this is you count the box 1, 2, 3, 4, 5, 6, and you go to the 6-digit numbers. Once you go to the 6-digit numbers, the fourth number is going to be 9. So you got 1 right here, and you see if there are any more. 1 right here, so you have 2. Okay, when you do, you're just checking now. You go to the 4 numbers, and the second number is a 6. There's a 6, there's a 6, there's a 6. Oh, there's a lot of 6s. There's a 6. So we're not going to do that one. The fourth number is four digits, and the second number is a 3. 1, 2, 3, 4, 5. See, when you do the 9 with the 6-digit number, you only have 2. So that's a good one. Okay. Second number is an 8, and it's a 4 digit. There's a 1. Let's look at that again. And so far, it looks like we're going to be writing this number. Okay. Second digit is an 8. It's that one. 3874. Just making sure. Oh, there's 2. Good thing we made sure. So we're doing 1, 2, 3, 4, 5, 6 digits. The fourth number in the 6th digit is 9. 1, 2, 3, 4. That's 9. And then there's a 9. Okay, so let's go with the 095,924. So if it's 6 digits, that means it's 95,924. And then so it's either going to be that one or that one. But what I'm trying to explain to you is do problems that just have you with your sight saying what the number is. And if you're ready to go to the next, because I'll do this. So if you're ready to go to the next problem of numbers placements, after you get to numbers placements, you're in your head just writing numbers or having somebody write a number. You solve the problem by putting the commas in the correct place, and then send me a picture of that in order to let me know that you personally, the one that wrote this question, personally send me a picture at 971-208-9711. And in your inbox, I will send you a link. Because with these videos here, I have an opportunity to make them private, and the only person that can open them are the person. That's how I'm sending out my personal lessons, okay? So with you having the link, you'll be the only one that go. If you see this on YouTube, it's not for you. It's just an answer to your question. But if you want to go further, because you might be ready for um, your next step, and I'll give you a quick test, and then I'll send you your next step personally. Okay? Thank you so much. And thank you for your questions. Continue to text me and let me know how you're doing by sending me pictures. My phone number again, 971-208-9711. And thank you very, very much.